Yeah, so this is just an overview, guys, of fire and some various aspects of it. So obviously I've picked up a wee bit of experience through both forestry management and also through my involvement with the rural fire brigades up in Marlborough and now down here in Canterbury. So I've cherry picked a few of the interesting stuff, a few of the interesting things out of it for you. There's a bit of an explanation as to how we manage it. So first of all, I'd like to start off with a question and maybe leave your mics on for this, because I'd like to know your answers to it. But what's the risk to forestry in New Zealand? We've got a nice green subtropical landscape down here. What is the real risk to forestry? Is fire simply a natural part of the environment that we work in? What's the risk? And a few ideas from you.
I think compared to other countries, it's probably pretty low.
Pretty low risk?
Yeah.
What about at the extremes? So if we're comparing ourselves to Australia, we are certainly a lot lower risk, obviously. Over in Australia, they have a lot of lightning strikes that'll start fires. They even have a bird that'll carry burning sticks away into unburnt areas to set them on fire and catch all the critters that run out of it. So we've certainly less risk than Australia, but in New Zealand we've still got the extremes, and we are a lot more densely populated in some areas as well. How much do you think burns annually? How many hectares do you think burns every year in New Zealand? No idea? We're looking at
20,000.
20,000? Maybe a bit high. But yeah, no, fair guess. If you dropped a zero off that, that's about where. So we're looking at about 2,000 hectares burning every year. One of the other question I was going to ask is, what do we value most? If we do have a fire start, and it's outside of it's not a house fire, it's a fire in the backcountry, what do we value most? Do we value the environment? Do we place greater value on the trees that it's burning? Do we place greater value on the property or infrastructure? Do we put greater value on human life? What's the most important thing to you if a fire gets started in the backcountry?
Probably number one, human life.
Human life, and then afterward maybe property, environment. Okay.
Assets, protecting the assets.
Assets. How about human health? Human health is a new one, and that's one that came up only not too long ago. And you'll all remember this one, the Pigeon Valley fire in Nelson, 2019. They moved huge amounts of people out of the path of the smoke there, simply to protect them from breathing issues. And this is something that's not really occurred on such a big scale in New Zealand before. So there's a cost involved in that. There's a cost involved in getting the emergency services to site, setting up, and evacuating all these people and housing them in the meantime. It's a real risk to forestry. We all know that. We understand that, and it's a risk to machinery, obviously. And this is unfortunately quite a frequent occurrence. Machines going up in flames, and simply due to electrical faults, debris build-ups, and that's just a fact of working in the forest. You know, debris build-ups happen, maintenance issues happen on machines. But that machine may have been worth the better part of $600,000, $700,000 before the fire went through it. Now it's worth nothing. So we've got an issue now where insurance companies are now, you as a business owner, you want to carry insurance for fire, but when the dollar figures start to get really high, an insurance company will come back and say, well, have you done everything reasonably practicable to make sure that that fire didn't happen? And in that case, and if they prove that that's the case, there's no payout. That machine won't be replaced. So, and the risk is beyond that. If it's not simply the machine that burns, it's the forest that burns around you, or even worse, it goes over the boundary and burns someone else's forest. You've potentially got a bill on your hands for that fire, for putting the fire out, and also the replacement cost of the trees or the infrastructure that it burns. So there's some pretty big things to deal with here when we're considering fire. And although we might consider the risk to be pretty low in New Zealand, as we talked about before, when it does get out of control, there's a lot of zeros behind the dollar sign there, potentially. But we can't be too scared of fire too, and that's one of the points of this presentation, is that it's also a land management tool, and we still use it. It's still okay. As long as we control it, and we've got some professionals in New Zealand that are used to using fire and for land clearance, and we've had this very situation recently with a helicopter there with drip torch on the bottom of it, where this was up in Marlborough, and they systematically burnt this gully, or this ex-pasture site, for planting. And you can see, without burning, this would have been a huge job to spray off or line cut before they plant the trees. But because they managed the burning properly, so this is before the burn, this is after the burn, since they managed the burning properly, they've got a beautifully clean site to be able to plant. So it's not all doom and gloom with fire. As long as we know how to use it properly and we use it safely, it's an incredible tool to use. So the basics of the fire triangle. This is firefighting 101. We all know that to be able to have a fire, we need three things, and one of them's heat, the other one's oxygen, and the third one's fuel. If we take one side of that triangle out, it falls over. So, and it's the basic premise of firefighting. So with water, you are removing the heat from the fire, and so you no longer have fire. If you're dry firefighting, which a lot of the rural firefighters are doing out there, cutting lines using bulldozers to make fire breaks, that's removing the fuel from in front of the fire front. Oxygen, that's a special case, often with those red retardant lines that they drop from helicopters. That retardant produces a chemical reaction that reduces the amount of oxygen available to the fire to burn. So we can fight fire with all three by taking out any one of these three aspects. This is an interesting one, and it was interesting to me. I didn't realise this until going through some of the courses with the fire crews, is that the flame doesn't actually burn the solid fuel. The log that you throw on the fire isn't actually what's burning. It's the gases that are coming off of that log is what's actually igniting. So as that log is heating on the fire, it produces gas that the flame is using to burn. So we've got these three phases at work at where the flame is interacting with the fuel. The first is the preheating, and that's where the flame is building heat on that within that solid, whether that be wood or paper or grass or whatever. It's building heat and it's converting those hydrocarbons into gas. The second phase is that gaseous phase where those gases are burning off, and that's the orange bit that you see. And then you've got the third phase, which is that charcoal phase, which is the embers that you see at the bottom, or actually embers is the wrong word, sorry. It's the coals that you see at the bottom of the fire. And that's when it can't produce enough gas anymore to hold a flame, and it'll simply smolder there in place. So there's three phases going on. As forest managers, we've got a responsibility to make smart decisions about how we plan our forests when we plant it. We've got a massive planting program going on at the moment. We need to be considering when we are planting our forests how these forests might be defended if a fire were to start in them, because you're dealing with, and you'll realize later on, a few slides will actually show you how much energy is encapsulated in these trees and is given off. But we've got a responsibility to be able to make sure there's appropriate access, make sure that you're minimizing the risk of fire transmitting over the boundary or throughout your forest, and actually giving our firefighters the tools to be able to fight the fires as well. A basic diagram of the most typical flame front, I guess, in a rural fire. So we've got the point of origin. We can see that at the closer to the bottom there, and you see that that's not in the middle, that's close to one edge, and that's because in this case here we've got a wind going across the fire. So we tend to see an elliptical shape where the fire will expand away from the point of origin in the same direction as the wind quicker than it'll burn back into the wind. And that makes a lot of sense, doesn't it? The wind is pushing that flame front further and further into new fuel, which is accelerating the rate of spread in that direction. You've got flanks, so they're obviously moving at a slightly slower pace than the head. They're moving out to the left and to the right of that origin. And then you've got the backing fire, which has got all sorts of names. It's the back, it's the rear, the base, or the heel. You see that on the picture there. And that's that fire that's slowly burning back into the wind, and obviously that's the slowest point. So if you've got a really good knowledge of the condition, if you haven't seen the fire before and you've turned up and something's ablaze, and you've got a really good knowledge of the conditions that were the weather conditions that were going on at the time, you can backtrack and do fire forensics and end up at that somewhere near where that point of origin might have been, to find out what started that fire. The firefighters talk about different sort of measurements of the flame. So we've got a flame in a burn pile here with two different measurements. We've got a flame length and we've got a flame height. Now the flame length is obviously from the ground or from where it's burning up to the tip on the angle, and flame height is the vertical distance from the ground up to the top of the flame. The reason this is important is because you can estimate the intensity of that fire, the number of kilowatts per meter that flame is putting off, by knowing that flame length. And that equation is really simple. Actually, it's 300 times the flame length squared, for your information. So if you knew that flame length was 5 meters, you've got an idea of how many kilowatts per meter that that flame is putting off. And you can see if you put any number bigger than 1 in there, that's a fire that you're not going to get anywhere near. So it's pretty impressive stuff. This one's really interesting, and it shows you, it's a really good example of how the fire propagates in a wind. So this man here that is walking along with a drip torch, he's intentionally lighting this paddock up, and we've got that stubble, that paddock stubble, is probably only about 20 to 30 centimeters high, but you can see in these conditions that flame length is up to, that looks like it might be 3 or 4 meters long. So you're looking at incredible flame intensities there that you would not be able to be anywhere near. But also you've got a big difference in the flame length depending on whether it's at the head, which is where you can see the smoke and it's advancing really quickly, or the tail, or the back, or the heel, or we'll call it the back, where it's slowly back burning back into the wind, or where he's lit it up. And quite possibly you'd be able to fight that with hand tools at the back end, but at the front end you wouldn't be able to be anywhere near it. So that was just paddock stubble. In a forest we've got a huge amount more fuel. We've got those lower level surface fuels, but we've also got all of the shrubs or the lower branches, the ladder fuels you see there, and the tree crowns as well. So depending on the intensity and the rate of spread of the fire, and to some degree the makeup of the vegetation that's down in this ladder fuel layer, you could have any number of different types of fires that are differing levels of danger, really. The point being, if your fire is managing to climb those ladder fuels up into the tree crowns, you've got something that no one's going to be able to get near for days. And this used to be one of the big reasons for using or for pruning around edges of roadways or anywhere that public gets access to. If you prune your trees, you're removing those ladder fuels from the trees and removing the chance of that fire getting to the crown and really doing a lot of damage. Not to say that damage can't be done by a ground fire. I've seen it's reasonably common to see forests that have been ruined by simply a ground fire going through and burning a strip or a cambium layer on the trees. Once that cambium layer dies, you've got a defect, often got a defect on the wood. So ground fires can do damage to the trees. You're by the time it gets to a crown fire, you're doing a lot of damage. So this is the that idealized shape that I was talking about before. Again, this is my drawing. It's not quite as good as the other one. But we got that origin there, that yellow origin, and then we've got quite a high wind speed in this scenario where it's pushing that head away from you. And you've got your backing fire, you've got those flanks. That head fire, the speed that head fire moves is determined by a few factors. And the first factor is obviously wind speed. We can understand that one easily enough. The available fuel load, and that's just how many, put it in terms of tons per hectare, how many tons per hectare of fuel is available to burn. And I mean available because it needs to be sufficiently dry, or dry enough, or can dry quickly enough by the heat of the flame to become available. So if you put a green log out there in front of the flame front, there's a good chance it probably isn't going to burn because it can't dry fast enough for the flame to catch it. But if you put grass out the front of it, it's going to dry really quickly, and then the flame's going to burn it. So available fuel load is something that determines how fast that's spreading. And you've also got the fine fuel moisture code, which we're going to cover a little bit later. And that's one of the elements of New Zealand's fire danger system. This is why it's so dangerous in varying conditions, though. And when there's an active fire, there's a lot of attention paid to the current wind conditions or current weather conditions, because if you've got a skinny, long fire like that with a head, and then you've suddenly got a wind change, everything that was a flank, and it's all burning, it's all ready to go, everything that was a flank is now a head fire. And you've got that same rate of spread, but over a much wider area now. And of course, if you've got crews stationed in those flank areas that thought they were safe, and they're caught by that wind change, there's a real good chance that they might be caught out. So wind conditions are critical. The weather also plays a role over the long term as well. So we all inherently know that during drought conditions we've got much higher fire danger, and that's a build-up of hot weather over a course of several weeks, and that's causing all of those. It'll cause the fine fuels, the needles, the leaves, those will dry out first. And then you start to get your larger sticks will dry out, and your larger branches and your logs, and everything is losing moisture over the long term. And that really influences how bad the fire is going to be, or how long it's going to take to put out. So once it gets into those large fuels, because you've had dry periods for a long time, it's much harder. It takes a lot more cooling water to stop those heavier fuels from burning. In the short term, and this can happen during the day, from early morning, it's often very cool and the humidity is very high, and your scrubs, or you say your gorse bushes, they carry a lot of moisture in the mornings. It might be very hard to get the fire started, but by the time you get to 1 o'clock in the afternoon, you've had a day of sunshine, you've had wind, you've had all these fine fuels have dried out, and now they'll very readily burn. So you've got this change that happens in the short term, and that's of your fine fuels, and then you've got this influence over the long term, which is your heavy fuels. So we've got this system in New Zealand called the Fire Weather Index system. It gives us the fire weather index in the end, anyway. And that's what we see on our signs out there. Our signs don't quite look like that. They've got a more descriptive, well, actually, that's probably a very good description of what we should be thinking. But it has a series of factors which lead into this final fire weather index that we see on these signs out in the backcountry. And that's the fine fuels, the duff. The duff is that top layer of stuff that's on the ground, dead litter, dead leaves, that sort of stuff. Drought code, that's more over the long term, how available are your heavy fuels, and then a couple of others, and I think I cover them a bit more in here. Yeah, so the duff moisture code and the drought code, together with your fire weather observations, and they're like your temperature, your relative humidity, and your rainfall. All of these factors get put together, and they come out with a build-up index number. And so this number is really indicative of what are the more longer term effects, or what's the longer term drying of those larger fuels, and how available are they to burn. And then we've got of the finer fuels as well, or this is the risk of the fire spreading or getting started first and then spreading. So fine fuel moisture codes, how dry are they particularly? the wind speed, and then we've got those same fire weather observations that are happening in the near past, like what's happened yesterday and last week, that sort of thing. So we get our initial spread index, and that's an index that's basically describing how likely a fire is to start. If you stand there throwing matches at the ground, are any of them going to start a fire? And then how fast is it going to move once it gets going? So we put these two numbers together, the build-up index and the initial spread index, to get our fire weather index. And that's where we draw the line between, is it extreme, is it high, is it medium, is it low, is it in the purple, because we're fast getting towards that sort of zone these days too. So that's the fire weather index system in a nutshell. So I said we were going to have a look at the intensities of what we might expect in a forest fire. In this case, I'll have to put this to the side so I can read it. In this case, we've got a mid-rotation pine forest. It's the middle of the fire season, so things are hot, things are dry. We've got a lot of fuel available to burn. We've got rolling hill country, 25-degree slopes, build-up index of 90s, getting up there. And we've got a head fire that's moving at 5 kilometers an hour. So that's a good walking pace. A good walking pace. That's how fast that's moving. How much fuel is available? And so this is a system that Scion has developed over many years. It's been based on an American system as well, but we've adapted it to New Zealand conditions. So we look up on these tables. We've got a build-up index of 90. Go down that left-hand side there, down to 90. And we've got a mid-rotation forest, so go across pine age 11 to 20. So we're looking about 25 tonnes per hectare available fuel. Remember, I was talking about available meaning it's dry, it's ready to burn. It's not total fuel like your inventory might say you've got 500 tonnes per hectare. That's not what we're talking about. We're talking about a fuel that the fire can burn readily. So 25 tonnes a hectare. We've got a basic fire intensity equation. Our intensity, I, is given by the multiplication of our H factor, which is basically an energy density. So our wood fuels are usually about 18,000 kilojoules per kilo. Our W factor here is our density or amount of fuel available per square metre. We've put our 25 in there, 25 tonnes per hectare, and converted that down. And our R is our rate of spread. It's that 5,000 metres per hour or 5 kilometres an hour. That's moving at about 1.4 metres per second. So plug that in, we're looking at 62,500 kilowatts per metre across that fire front. So every metre that you step across that fire front is putting out 62,500 kilowatts. And if you think about that, your standard heater inside might be 1,000 watts or 1 kilowatt. So that's nearly 63,000 of those 1 bar heaters per metre along that fire front. And there's a little conversion there down the bottom. That's burning the same amount of fuel that 950 petrol-driven cars would burn at the same time per metre as well. Or I think in another, feed it out another way, that's 1.8 litres of petrol burnt in a second. And we've all burnt fuel. We know how much, fuel's rather hot, but that might be only burning a millimetre or less a second. That's 1.8 litres basically instantly burnt. An incredible amount of energy in that. So knowing that, we need to be prepared, because if we get a fire that's going ballistic like that, and it's in the crown and it's burning, we're really waiting on nature to put it out. We can't stick a machine in front of that. We can't put helicopters on it and assume they're going to be able to put it out. It can't, and won't be able to in the near future. So we need to be ready, and we need to be actively trying to avoid fires starting if at all possible. So what that means for forest management practices is meaning you need to have your maps up to date with your roads. If that fire front's coming at you, you need to be able to get out ASAP, because you're not going to survive that. Fire breaks put in. Sometimes they help, sometimes they don't. Ponds, they invariably help for the cleanup. Really, they don't really help for the initial attack, because there's no way you can put people in that sort of environment, but they'll speed up how fast the fire is actually finally put out. Access roads, make sure people can get access. Signage, stopping people accessing in those really high risk seasons. Removing the ladder fuels in the high risk areas. Most of the fires in New Zealand are caused by people. And so you can pretty easily draw a line around all infrastructure and say that people are probably going to be close to infrastructure. So removing ladder fuels in high risk areas where people might, or you might see a lot of access by people, is a really realistic way of mitigating that risk somewhat. I put seasonal access control there for if you do have extreme fire conditions. It's probably best to be careful who you're letting into the forest anyway, fencing and gates. So NZFOA's got a guide that can help out with fire management, give you an idea of what some pragmatic steps you can take to minimise your risk. And we can also look to the fire service as well. So the fire weather system that I was talking about earlier with the build-up index, the initial spread index, the moisture codes, that's all available online, and you can dial up at any time on the FENS website and look at what your fire risk is in your area. So this is an example in North Canterbury where they've even rated it for you, where you got very high or extreme or high based on all of your indices there. So I think that covers what I was saying before about most of them are started by people in New Zealand. We've got a tool, and we can use that tool to be able to set limits around who's accessing and why they're accessing, or what types of activities we're allowing in our forest within these high danger periods or low danger periods. We've got some measurements to base that on, just not just a finger in the air to say, yep, you can go and do your welding. An example of that is an activity management guide that was put out by FENS up in, so this one is Marlborough Kokora. It was also used in Nelson as well. So in this case, when the fire danger rating was up in the red, they advised that you should probably restrict public access, consider putting up signage, make sure that you'll stop all your roadside mowing and slashing, stop your chainsaw operations after a certain time during the day when the risk level gets up, and then also some cable logging specific ones as well about when and how they can work. So this particular guide covered everything right through to code purple, I believe, which was very extreme or something, catastrophic maybe. Yeah. And the other part's being prepared. So having communication plans, having your escape routes, having training as well for dealing with it. And just like we run our our emergency response for someone breaking their leg in the forest, we can run trainings for fire preparedness too. Fire's been called in. What do you do? And it's over there. What's the right approach? Given this is what information we've got. So be prepared. Do your training. Get in touch with your local branch of FENS that are likely going to be putting it out if it gets out of control, so that you've got those communication lines there already. And refer to those NZFLA fire management guidelines as well. And over the long term too, because this is where you guys really come in, is that we've got we're starting to see climate effects now, we believe. Some of the modelling that's been done by Scion and NIWA is saying that these fire seasons, although we're still going to get a winter and a summer, and we're going to get more intense rainfall, we're also going to get more intense hot summers as well, or more months or more days spent in that high risk fire danger or high fire danger time. So, and you can see that expanding all over New Zealand there. So at the moment we're fairly well yellow everywhere to red, but some of those areas are going to get more intense. So interesting, and something to bear in mind too with forest management, and especially planting management as well, because there's a real opportunity when you're planting to get it right the first time rather than trying to fix mistakes. So that's the end of my fire presentation, guys. I hope you got something interesting out of that.